and get started, we're going to first talk about the range. The range is really basic. You've probably seen it in the past. Oops. It is just the highest value minus the lowest value. So R is equal to the highest value minus the lowest value. And we have this example with outdoor paint. So it says outdoor paint, we have 2 experimental brands of outdoor paint. They're tested to see how long each will last before fading. 6 cans of each brand constitutes a small population. The results in months are shown. Find the mean and the range of the group. All right, so we're gonna go ahead and do that. So for brand A, and I'll write brand B over here. We're gonna go ahead and do the range, which of course is just the max minus the min. And so for brand A, my highest value that I see is 60 minus my lowest value, which is 10. So 60 minus 10 is 50. So 50 would be the range for brand A. And then for brand B, I would do the same thing. I would find my highest value, which in this case is 45. And I would subtract that from 25. So 45 minus 25, which gives me 20. And then I will give you a moment to please find the average, the mean, which remember that can be written as an X with a bar on top of it. So I'll give you a moment to find the average of A and B. And if you would like to, you can type the that answer into the chat. All right, thank you for those of you who have already found it. You guys are pretty fast. You just add all of these numbers together and you divide by the total. So the total of numbers that we have, of course, is 6. And when I add these together, I get 210 and 210. But we have 6 of our numbers. So it's 210 divided by 6. So basically, I'm getting an average of 35 for both of these. But as far as like which product I would want to pick, I would want to pick the one that has the lower range, which would be brand B, because even though they both have an average of 35, if I pick brand A, I might get the one that only lasts for 10 months, which doesn't really seem fair when the average is 35. But if I pick brand B, then since the range is smaller, it's more likely that I will have something closer to the average, which would be ideal. Okay, so sometimes they're going to have the same average, but they're going to have other differences, which would help us to pick the right one. Okay, so we move pretty quickly away from range because we're now going to get into measures of variation, which include variance and standard deviation. So here are some of our definitions. So we have the population variance, which is just the average of the squares of the distance. Each value is from the mean. So it's the average of the squares of the distance. Each value is from the mean. We have the standard deviation, which is the square root of the variance. And so you're going to see that one of the reasons why I like to do this by hand first is so you can really kind of understand what's going on with these numbers. So like if I was buying paint from Home Depot and we were actually comparing brand A and brand B, I would also want to know the standard deviation. How much does the product deviate from the average? And that's really like what we're finding when we find the standard deviation. So we're going to use variance and standard deviation to determine the spread of the data, to determine the consistency of a variable, to determine the number of data values that fall within a specified interval in a distribution, which is Chebyshev's theorem, and we'll use inferential statistics as well. So the population variance is given by this formula and that symbol as well. And so really that's going to be the sum of the data value itself minus the average, so how far does it deviate from the average, squared divided by n, and then the population standard deviation, so the standard deviation has its own symbol right here, and that is the square root of the variance. And your calculator will do this for you, but like I said, I want to do this by hand because I think it's kind of important for us to see what it looks like by hand and to not just type it into our calculator, even though the calculator is going to be a lot faster. And there's some information as well that I want to give you about these different variables in your formula. So once again, we have this symbol is the notation for variance. And then in the formula, I just want to point out that x is the data value. And then mu is the mean. And sometimes they will actually go ahead and give you that information, and sometimes you'll find the average yourself. But we've been finding the average a lot, so that's not too big of a deal. And then n is the total number of values. And then just a reminder that, of course, for the standard deviation is just the square root of the variance. And your calculator will give you both of those numbers, which is kind of nice. So what I'm going to do is I'm going to show you an example that's already worked out, and then we're going to work out an example together. So I'm going to show you kind of like what that table looks like, and then we're going to do our example together. All right, so it's okay if you don't completely follow it. I think when we start to do it, our own example, you'll definitely be able to see what's going on. Is it okay if I click? Can you guys give me a thumbs up? Okay, thank you. I don't want to go like too fast. I know sometimes I just go crazy. I have coffee and a lot of energy and I just go on and on and on. Okay, so here are the steps to find the population variance and standard deviation. So first, of course, we would need the mean or the average of the data, which we've already done on our warm-ups, right? We just add the numbers together, divide by the total. And then we want to figure out the deviation for each value. So that is really important because that kind of tells you how much does it vary from the average. So if you think about like your quiz scores, some of you got 100 on your quiz, some of you got like a 70 on your quiz. And let's say the average was like an 85. Well, if you know the average, you can kind of see, okay, how much was my score different than the average? And so that's really what that measurement is taking when we subtract it from the average. However, since we subtract it from the average, sometimes we're going to have negative numbers. So sometimes, like let's say the average was 85 and someone made 100. Well, 100 minus 85 is 15. But let's say someone made a 70. So then we do 70 minus 85, which is negative 15. So we want to account for the negative part and we don't want it to mess up our data, which is why we have to square it. So as you remember, if you square a negative, it becomes positive. Okay, so we'll do that. Then we will find the sum of all of that information for each data point, and that will help us to actually calculate the variance and the standard deviation. Because once we have that sum, we can divide it by the number, and that will give us the variance. And then we'll take the square root of that to undo the fact that we squared everything, right? So we have to undo the fact that we squared things. And then that will give us that standard deviation. Okay, so I know that's a lot. And like I said, I'm going to show you one that's already filled in, and we're going to do one together as well. And then I'll show you how you get this on your calculator too. Okay, so let me scroll down a little bit to show you how that looks. So here's our data, and this is outdoor paint. We have the variance for brand A. And so here's our X. This is our data set. This is information they have to give us. So we have to have at least that information. From that information, we can find the average. It's already been found for you, of course. The average is 35. Okay, so that's that mu right there. That's the little symbol we like to use. That is the average. Let me write that here for you guys. Okay, so this is the average, or the mean. Should use the word mean more often, right? That's our average. We take each number in our data set and we are comparing it to the average. So for example, the average is 35, but that first data value, 10, that differs by negative 25 from my average. That's kind of crappy. I wouldn't want to be the person who gets the paint that doesn't last very long. Okay, that's a negative 25. That's not good. But all I did was 10 minus 35 to get negative 25. So how far away is it from the average? Then I square it, because we always want to square it to get rid of those negative numbers. So I end up with 625. And then we have the number 60. I do 60 minus 35, I get 25, I square that, I get 625, and so on. And so for each number in our data set, we are comparing it to the average. Once we find that number, then we are going to square it. And I have to tell you, I apologize for this. We were supposed to fix this. There should be a little squared there. So if you'd please scribble in the squared, that's missing off of our table. So we square that information. Okay, once we have all of our squareds, we then add all of these numbers together to get our total, which they have also already done for you. Okay, so this is the summation. This represents the sum. Remember, this symbol here is just the sum. The sum of each data value subtracted from the average squared divided by the number of values that we have. And of course, we have 6 data values, which is why we divide by 6. When we do this, we get 291.7, which is our variance. We will take the square root of that to get our standard deviation. In words, that means that that paint for brand A deviates from the average, on average, 17.1 months. Okay, so a smaller standard deviation would be ideal, because that means whichever paint I grab, there's just a little tiny chance that I'm not going to get that as many, I'm going to get closer to the months of the average. So 17.1 is how far it differs from the average on average. Okay, let's do one together. We'll do it by hand, and then I'm going to show you, of course, what this looks like in your calculator, because depending on how many numbers you have in a data set, it might not be the best idea to do this by hand. Does anybody have a question? I feel like someone's unmuted. Anybody? Okay, I think we're good. I'll just mute the person. So if I ever mute you, please don't take it personal. Okay, so let me go to the next one. So we're going to do this by hand, and then like I said, we'll also do this in the calculator. So it says find the population variance for the following data set. So you also want to think about, okay, what is it asking me? Is it asking me for the standard deviation, or is it asking me for the variance? So for the variance, that is, there's our symbol, and we don't take the square root at the end. We would just have that sum number, okay? So I'm going to give you a moment to take this data off to the side and I would make a little table, right? We're going to keep this like really organized, because this is kind of a lot of steps, okay? So the first thing I want to do is create a little table. I'm going to start with X, and that's 26, 28, 16, 23, and 20. Okay, then I want to go ahead and find the average, the mu. So here we go. And I will give you a moment to find it. And as Matthew pointed out on the warm-up, we only want to round one decimal place because all of those are whole numbers. So I want you to find the average and type it into the chat. So I'll give you a moment to find the average. 22.6 is correct. And so that 22.6 is going to be the average the whole time. So you can choose to write it that many times or just write it once and draw like a line down, however you want to do it. Okay, so there is my average. Now I want to compare each value in my data set to the average. So I'm going to do that by subtraction. I need to figure out how much does it differ from my average. So I'm going to do 26 minus 22.6, 28 minus 22.6, and so on. So I'll give you a moment to do that on your paper, and of course I will do it on my iPad so you can kind of see it. We can just fill it in together, okay? So I'm going to work on that part. I'm going to go ahead and put this in for you. So remember, we're just doing 26 minus 22.6, 28 minus 22.6, and so on. I don't really have enough room to show all of that every time, but you should end up with like 3.4, and then I'll give you a moment to do the rest, and I'm going to quietly write these in. All right, do you agree with my numbers? Thumbs up? Because as you know, in this class, we've already had this happen at least once, right? One wrong number, the whole thing is messed up. Okay, so I really need us to make sure we're like following along and helping out. Okay, good. All right, now we're gonna square. So the next step is to think about the fact that we have these negative numbers. We're gonna wanna square the numbers. So that's gonna be x minus mu squared. Okay, that's our next column. So I'll give you a moment to square those numbers. I will write them in my table. And this time, since all of our numbers are one decimal place, when we square them, we're gonna wanna go 2 decimal places, all right? So now that all of these are 1 decimal, as we're working this out, we wanna have 2 decimal places on that next column, all right? So I'm gonna write in what I get, and you please follow along. All right, do you agree with my numbers? Yes? Maybe you're still doing it. Okay. So I'll give you a moment to make sure we agree.
I have a question.
Sure. Now that we have this column, we need to find that sum. So the sum of each data point compared to the average, and then we squared it. So we're talking about this column here. So we need to add all of that together. So I'll give you a moment to add all those numbers together. And then we will eventually divide by how many we had. Okay, so the variance is equal to, of course, the sum divided by n. But let's find that sum first. So you should be adding all those numbers together. Alexander, thank you. You helped me out. Alexander got 91.2. Do you agree with that number? When you added all these together. Okay, awesome. Now we're going to take the 91.2 and we need to divide it by how many data that we have. So we have 1, 2, 3, 4, 5. So n is equal to 5. So we want to divide that by 5, which gives us 18. 0.2. And let's see, so did you get 0.24? 18.50. Okay, so I'm going to go ahead and put 0.24. But I just want you to know that on our answer choices, you can see they only went one decimal place. Okay, so like sometimes they're going to go farther and sometimes they're not, and that's okay. We would definitely want to pick the 18.2 in this case. Okay, so that's our variance. Now, if we wanted, I know it's not asking you for the standard deviation, but we should go ahead and talk about the standard deviation. So if I wanted the standard deviation, all I would need to do is take the square root of the variance. So that would be the square root of 18.24. So that would be so this is my variance. That's what they were asking for. But, hold on a second. Looks like I lost connection there. There we go. Sorry about that. Weird. Okay, so our standard deviation, we would take the square root of that. So let's take the square root of that and see what we get. And then I'm going to show you what that would look like with your calculator. So the square root of 18.24 is approximately 4.271. All right. Now let's put this in our calculator to see what that looks like. Okay. Is it okay if I go off of this screen? Should I wait a second? I think some of you are still writing. Okay, so I'm talking about the different types of variance and standard deviations that we can have. So a population variance and standard deviation is just basically we have all of the population of something that we're using. When they give us a sample, and they'll use the word sample variance, sample standard deviation, we are going to use this formula whenever they give us that. And so they're just giving us a sample of a greater population. So the number of values that we have is included, but we do subtract one from that. Okay, so these are just more formulas that we have. And we're going to be doing an example like this as well. And as far as this goes, there is also a different formula you can choose to use for this as well. Okay, so there are more than one way to do this, and it seems like the way that we like to do it is actually right here. Okay, so we're gonna really talk about this formula because it's actually a little bit more straightforward and a little more convenient. Okay, so let me scroll down here. So we're gonna find the sample variance for the following data set, and we're actually going to use that second formula. Okay, so let me write that here for you. It's just right here. So the sample variance is equal to, so we've got S squared. We're going to find these values and, square. Okay, and then n minus 1. Okay. Let me kind of go off to the side to show you what that would look like. All right, so the first thing I want to do is I want to go ahead and declare what n is. N is equal to 5 since there are 5 data values. All right, so n is equal to 5. And then to find the sum of the data values squared, so we're going to now find the data values squared, the sum of that. So this is a really convenient method. What we're going to do is we just take each of our numbers and we're going to square them and add them together. All right, so that's going to be, let me do this in a different color. So I'm going to have 25 squared plus 20 squared plus 19 squared plus 15 squared plus 31 squared. Okay, so I'll give you a moment to find that number. And let's see. Okay, thank you. I think Dylan got it fastest. 2572 is correct. So I find the sum of that. And then the next thing that I want to find is just the sum of the x's itself. And so I can just add all of the numbers together. So 25 plus 20 plus 19 plus 15 plus 31. So I'll give you a moment to find that number. Okay, I think Matthew already found it. That was fast. Okay, so that's 110. Okay, so I find the number of the squares. Oh, no, it's okay. I'm glad you're saving us time. I find the numbers squared and add together. I also add just the numbers together. And so I get 2572 and I get 110. Okay, so by hand from here, so I'm going to put by hand. I'm going to have the sample variance is equal to, and then I'm going to do this formula here. Okay, so bear with me. This is n, so n is 5, times the sum, which we have right here, the sum squared, right here. Sorry, that's kind of going off the screen. Let me move it down a little bit. Okay, so we have 2 times right here, this part, which is 2572. And then we have in our formula minus 110 squared. Now I'm getting 110. That is just the values added together. But I do need to square them. So I am comparing the fact that we have the total number of the squares is 2572 times 5, because that's how many we have in our sample. And then minus 110 squared divided by 5 times 5 minus 1. So the 5 and 5 minus 1 is down here. So 5 times 5 minus 1, which would be 20 on the bottom. Okay, so I'll give you a moment to find that number. So this is like, at this point, you can carefully type this into your calculator, or if you want to do it piece by piece, I'll write down what you should get if you do it piece by piece. Okay. Are there any questions about that part? Because I'm going to show you how to do this in your calculator as well. The difference between this and the other way that we did it is the other way was for like a whole population. If it says sample, you have to take into consideration how many of the data set that you have. And in our formula, that's why we have that n and then times n minus 1. And I'm going to show you what this looks like in your calculator. But are there any problems with getting 38 from these steps? Okay, so let's take a look at what it would look like with our calculator. So when we do one var stats, we do get the sample standard deviation, which is denoted S of x, or Sx, which was 6.144? 6.144, okay, thanks. And then we can just square that. Yeah. Oh, no, wait, it was 1644, sorry. Okay, we can square this to get our variance. So when we square it, we got 37.99, you know, which would round up to 38. Now, if they ask you for sample standard deviation, that would just be the SX of your data. And if you wanted to do it by hand, you would just take the square root after you do the sum part, okay? And so that would be something that you could definitely do by hand. In fact, we'll go ahead and do one of those by hand. So we'll do one more like that to show you, okay? So I think you're gonna be okay as far as calculator-wise. You feel free to come back and make sure you're getting these numbers. Just remember that for the standard deviation, they're gonna outright give you that 8.2. That's gonna be the SX, okay? And we use this for sample, standard deviation, sample variance. Okay. Can I go to the next slide? Are you guys good? Okay, so talk about, and like I said, there's also videos available for you that that might help you, especially if you have like the other calculator, if you have a TI Nspire that you might want to watch those videos, that might help you. Okay, so we're going to do, I at least want us to do one by hand for the sample variance, and that way you're getting that by hand. Okay, so for the sample variance, we are going to have to, basically, we're going to do like the similar thing we did for the, sorry. You know what? I have a different, where did my number 3 go? I'm sorry. We already did the sample. We want to do the standard deviation, my bad. So let me go up to this one. Let's do the sample standard deviation because we haven't done that yet by hand. Okay, so we're going to follow that same formula, but we're going to be taking the square root. So to find the sample standard deviation, which is what they're asking for, we're going to be taking the square root of the sum of the values squared minus the values, the sum of the values squared. Okay, but that order is different, so we're going to talk about that. And then divided by n times n minus 1. And of course, we have our n up here as well in our formula. Okay, so this is just one of our formulas. And the cool thing about this class is you don't have to necessarily memorize the formulas because you get to use your notes on your test anyways. But I would use that formula sheet to help me, since your test is like timed. Okay, oh, looks like they have the formula. Oh, that's for the next part. I am so sorry. This is like not in a good spot here because they're talking about frequencies. So that's something else I'm going to tell them we need to fix there. All right, so let's go ahead and get started. First, I want you to find the sum. Let's go ahead and find that sum of all the values and squared. Okay, so that would be 15 squared plus 22 squared plus 28 squared plus 16 squared plus 18 squared. Then I want you to find the sum of just the x values themselves, which would be 15 plus 22 plus 28 plus 16 plus 18. Okay, and then we'll go from there. Oh, somebody's already helping. You guys are so nice to help out. That's really, really kind of you to go ahead and give me these numbers. Okay, so let me see. What numbers do we have here? We have 2073 and we have 99. Okay, so I'm guessing this must be 2073. And then this must be 99. Okay, do we agree on these numbers? I need at least a few people to agree before we move on. Okay, I see some thumbs up. So we agree with both numbers. Okay, so now it's just a matter of plugging it into our formula. All right, so we're going to have the square root of, we're going to have n, which is 1, 2, 3, 4, 5. So n is equal to 5. Oh, yeah, go ahead. What's up? Oh, thank you for telling me that. Sometimes it does weird things. All right, so then I'm going to have 5, which is, of course, the n. This sum here, which you guys gave me, is 2073 minus, and then we have 99 squared over 5 times 5 minus 1. Whoops, sorry. Whew, it's a lot. Okay, so we're going to figure out what that number is. And depending on how you are with your calculator, you could probably type that in all at once. I'm just going to do piece by piece for you just to show you what that looks like. So that would be 10,365. And then 99 squared is 9,801. Okay. So 564, and this is just 5 times 4, which is 20. All right, how are my numbers? Do you agree? Have you been following along? Well, we'll find out, right? Because we're going to check it with our calculator too. So 564 divided by 20, just 28.2. Okay. Now you can see this is not nice, but see how they give you 28.2 as the answer choice, but it's asking for the variance. I mean, the standard deviation, not the variance. Okay, so this would actually be 28.2 would be the variance. They want the standard deviation. So I take the square root of that. And then when I take the square root of that, so the square root of 28.2, I get approximately 5.310, which is, of course, my answer. Whew. Okay, so now I'm going to put this in the calculator to show you real quick, and then we're going to move on to the part that someone told me to skip it. I don't think it's a good idea to skip it because it's like the only one you can't really do in your calculator. And there is a backhand way to do it, depending on your calculator. Okay, so let me finding the sample variance and standard deviation for grouped data. So this is different, right? Because we don't actually have the data values. We have the class and the frequency, but we don't have the actual data values that we would need. And so when they give you this, they're going to have to give you enough information, and that would be the classes itself, and they would have to give you the frequency. You have to find the midpoint. So to find the midpoint, just a reminder, you're doing what we did previously, where you would just add the 5.5 plus 10.5 together and divide it by 2. And then add these together and divide by 2, and that's going to give you the midpoint. Okay, and then from here, we're gonna utilize this formula. So you can see the formula is actually quite similar to the one we just had. So we're gonna use this formula here to get the variance, but we have to take into account that there's frequency involved. So we're going to have to figure out a few things for that. All right, so what we're gonna do is we're gonna multiply the frequency by the midpoint. Let me just draw a line here. Frequencies by the midpoints, and that's going to quickly give us our values that we will eventually add together. All right, so we're going to multiply the frequency by the midpoint, and then we can find the sum of that, of course, by adding them together. All right, so this would just be 1 times 8, 2 times 13, 3 times 18. So I'm just multiplying these numbers together. And so I'm going to just record those for you. And, oh, this is like number 13 on your homework for this section. So I just wanted to point that out. This is like number 13 for section 3.2. Okay, then I want to multiply the frequency times the midpoint squared, all right? So this is going to be frequency. So just remember, F, of course, means frequency. So it's frequency times the midpoints squared. Okay, so for example, I'll do this in blue. It would be 1 times 8 squared, 2 times 13 squared, 3 times 18 squared, and so on. So I'm going to draw that out for you. Okay, so I'll give you a moment to find all those numbers, and then we're going to add them all the columns. We'll add that part together. So I'll give you a few minutes to do that. All right, let's see if we agree on our numbers. All right, did you get the same numbers I did? Okay, now I need your help again. We are now going to be adding the columns here. So we need to add all of these numbers together. And we need to add all these numbers together. Okay, so I'm going to give you a moment to find that. And if you want to type it into the chat, that would be great. And then we'll put this all together and I will show you kind of a roundabout way that your calculator will help you with a few of these numbers, but your calculator won't just outright give you the answer. All right, so that's why I want to do it by hand first. All right, I already see some discrepancies with our adding, which does happen. Okay, so we want to be very careful because it's really easy to make one mistake when you're adding these together, right? So I see 490 a bunch. Okay, so I also got 490, so I think 490 is fine. If you're off by just a little bit, it happens. Believe me, it happened to me last time, right? So this should be 490, so that's the sum. Okay, and then the sum here, when I add all those together, I got 13,310. All right, so I think we're good because enough people have that. All right, so here is the formula for variance that we'll be using. And it looks like this. So we have Rn, we have the sum of the frequency times the midpoint squared, which we found, minus the sum of the frequency times the data points added together squared over n times n minus 1. So this is pretty complicated because we have frequency involved. So it's just requiring us to do more work. Since we weren't outright given the data points, we had to find the midpoint. Okay, so plugging this stuff into the formula, because we've already done a whole lot of work here. The n is equal to the frequencies added together. In this case, n is equal to 20. I'm not sure if you had a chance to add those together, but you do need to add those numbers together. Okay, so that's going to be my n for this. So I'm going to have 20 and 20 minus 1. Then I have 20 on the top, and this value comes from this column right here. So this is basically, we've already done this. It's 13,310 minus this is from our sum of frequency times each midpoint, which we already added to get 490. We do need to square it though. Okay, so this is one of the more complicated formulas that we've ever had, right? So I'll give you a moment to work that part out. And then I'll show you how this does relate to our calculator. But there's a few little special things we have to do to be able to do this in our calculator. And it has to do with the frequency itself. All right, so I'm going to go ahead and show you what I got when I worked this whole thing out. Okay, good. It looks like you guys are definitely on the right track. I just went a little far on my decimal. It's like my nature, I can't help it. But this will be the variance. So if I wanted the standard deviation, I can just take the square root of that. So depending on what they're asking me for, and a lot of times they're going to ask you for both. Okay, so once again, this is our variance. We take the square root, we're going to get the standard deviation, which is approximately, and I put 8.2, and I didn't go like super far. But I want to show you how this looks in our calculators. So let me go back to my calculator. Is it okay if I go back to my calculator? Can I get off this screen? Okay,